I want to talk to you guys a little bit about your grade 11 end of your paper and how it's set up and what some important things to do when you actually start your paper. Okay, so I'm starting with a blank sheet, right? So obviously there's no exam paper yet, okay, because I want to talk to you about how that paper is actually set up. So November paper, end of year. All right, paper 1 and paper 2. Let's start in general for now. Okay, so November, paper 1 and paper 2. Let's talk about levels, first of all, and difficulty. Okay, because my worst is when I get students and they're like, man, the whole paper was so hard. Guys, no, the whole paper is not so hard. Okay, what they do when they set up your paper, and now this is high school, so from grade 8 all the way to matric, all right, but mainly when we're looking grade 10 to grade 12 and we're looking at our levels, what they call levels, all right. In grade 10 to grade 12, there are 4 levels in your exam, all right? So every test, every worksheet, assignment, whatever it is that you do, but especially your exam, the paper is made up of 4 different levels, all right? So these 4 levels come from the CAPS document, okay? So what I mean by that is that every single teacher has to stick to this. Every single school has to stick to this, all right? It's not like they can make up their own rules, all right? They have to stick to these levels, all right? Level 1 questions, okay? Level 1 questions are your nice questions. They're those questions that you guys like pray for in the exam. They're those ones that you like, when you see them, you're like, oh my goodness, thank goodness. The ones that you always forget to study for, first of all, because everyone's like, oh, that's easy, I can get that, that's easy, that's easy, that's easy, all right? It's what we call knowledge questions. So level 1, we call them knowledge questions, okay? If we're looking at questions in paper 1, all right, that would be examples of knowledge questions. They would kind of be like looking for the domain of something. They would kind of be like looking for the equation of a straight line, like those kind of questions. Okay, really nice, basic knowledge type questions. Okay. Level 2 questions. Level 2 is what we call, routine procedure. Okay, so level 2 questions are what we call routine procedure. So in routine procedure, you're looking at things like estimation and appropriate rounding of numbers. In these kind of questions, proofs of prescribed theorems, okay? You're looking at things like identification and direct use of the correct formula, okay? So you're looking at things like getting the right formula from your formula sheet, performing well-known procedures, simple application of calculations, all right? So those are your routine procedures. Level 3, now you're getting a little bit more tricky. So these are your complex procedures. All right, so these are problems involving complex calculations, okay? There's no obvious route to the solution, right? Problems need to be based on a real world context, okay? They could involve making a significant connection between certain issues, all right? And they require some sort of conceptual understanding. So here, these kind of problems, you could have done these ones in class. So you could have seen these ones before, your teacher might have gone through them before, but these are more complex ones. And the final kind of questions that you get are what we call problem solving. Now, level 4 problem solving, these are the kind of questions where students come out of the exam and they're like, you didn't teach us this question, okay? You guys all know these questions, all right? You've seen them before, all right? It's the kind of question where you walk out and you're like, oh my gosh, question 7, the last question of the paper was so hard. I spent half an hour doing it. Ma'am didn't ever teach us that in class, okay? Those kind of questions are non-routine problems, all right? They don't have to necessarily be difficult, okay? But they require some kind of higher order thinking, right? So they might require you to break down the problem. They don't necessarily require you to have been taught it in class, but you have to take something that you've learned in maths and you have to apply it to the question. Now, why am I telling you all of this, guys? Because of your total paper, okay, of your total paper, all the questions in your paper, 20% has to be made up of knowledge type questions. So 20% has to be made up of your really nice, easy stuff that you can learn, stuff that you can practice, stuff that we're going to go through in your workshop kind of questions that you can do today. 35% routine procedure. Nice, easy, again, stuff that you can practice, stuff that you can get right if you do enough of it. All right. So that means that if you do enough practice, okay, and enough papers, and you work through enough questions, all right, it means that minimum 55% for maths, just from level 1 and level 2 questions. Those are the easy questions in your exam. Minimum 55%, okay, is just knowledge and routine, all right. Complex, so your higher order questions now, the ones that are slightly harder, okay, this is 30%. All right. So if you're looking to break into, all right, those 60s and 70s now, okay, the 60s and 70s and getting into the 80s, then you need to start looking at your complex procedures. So this is where the hard graft starts coming in. This is where you need to start really working hard at your maths. You need to really put in the effort. You need to really put in the practice, which is why you're here today in this workshop. And problem solving, 15%. So those level 4 questions, those questions where you're like, man never taught us this, it was so hard, that is only 15% of your paper. So even if you don't get to that question or you don't finish that question, you can still get 85% for maths, paper 1 and paper 2. Okay, so even if you don't get to that extremely hard question, it should only be 15% of your paper, which means you can still achieve 85%. All right. So why am I telling you all of this? Because what is going to be your friend in your maths exam, okay? Especially in grade 11, end of your exam paper, timing. Guys, timing. You need to make sure that you are sticking to time allocations. All right. I am sure that you have heard it before from teachers. Mark per minute. Okay. I know with my students, I say it over and over and over again, especially when it comes to exam time. Okay. I talk about it all the time. Mark per minute. I go on and on and on and on, and my students actually get so mad with me. But mark per minute is so important. All right. If you are taking longer than a mark per minute in your exam, you are wasting your time. Okay, you really are wasting your time. You need to make sure you are sticking to that mark per minute timeline. All right. If you're taking longer than a mark per minute, you are wasting your time. Okay. In other words, all right, if the question is for 2 marks, you're taking 2 minutes. If the question is 3 marks, you're taking 3 minutes. The question is 5 marks, you're taking 5 minutes. Do not get stuck in down that rabbit hole of some students who are like, oh, the question's 5 marks. Oh my goodness, I need to spend 20 minutes doing this question because it's so hard. No, 5 minutes, 5 marks, 5 minutes, move on. All right. That's what you need to be sticking to, timing. Okay. All right. Really great question in the chat. Cassandra's asking, how and where can we practice level 3 and level 4 questions? Cassandra, the best place to practice level 3 and level 4 questions is to go through past exam papers. Okay, go through past exam papers, get as much practice as you can. Okay, get as much practice as you can. And then when you are in the exam, like I said, level 4 papers are all going to be different questions each time. So your level 4 questions are going to be different, okay? You hardly ever going to see the same level 4 questions. They're going to change all the time, okay? But do as much practice as you can. All right. Mr. Hugo's put a really great site in the chat for you guys for some extra practice. Siavula, it's a free site for extra practice. Another great site for extra practice, I'll put some extra sites for you guys in the chat at the end as well, all right? But if you go to Google, guys, and you Google grade 11 past exam papers, there are websites that come up, all right? The Eastern Cape Department of Education has a fantastic website where they've got all their past papers lists, okay? Then you've got another site, it's called, I think it's called Stanmore Physics. I don't know why it's called that, but it's got all of the Free State papers, and it's got the KZN papers, and it's got the Limpopo papers. It's got all those exam papers. Try to do as many papers as you can. That is the best way to study for maths. When you're studying for maths, you cannot just open the book and read. You have to practice and practice and practice, pen to paper. That's how you do your maths. Okay, so I hope that you've got this. Take a screenshot if you want of this. Okay, this is a really important thing to keep reminding yourself of all the time. Your level 3, your level 1, 2, 3, and 4 questions, how you can actually achieve at least minimum 55% for a paper. All right, and if you're going for your level 3 and your level 4 questions, that's how you're going to achieve your 60s, 70s, and 80s. Okay. Tando's asking, are we going to be doing level 3 and level 4 questions in the workshop? Tando, of course we are. Of course we're going to be looking at them today. Of course. Okay, so we're going to go through a whole mixture of the questions. We're going to see how to tackle them one at a time. All right. Is there anyone who has any questions on these levels, how to look at these levels, that kind of thing? Are we good? Are we happy to get going? Anyone, any other questions on this? All good. Okay. All right. So you guys would have been sent a paper. Oh dear, sorry guys. Earlier on in the week. Okay, let's get that paper out. Okay, so you would have been sent a paper earlier on in the week from Watobe. Okay. I have set that paper according to the levels again. All right. I've put a variety of questions in. I've set it up so that it's structured exactly like a grade 11 final paper that you would get. Okay, so it's a really good practice paper for you to do, right? And that's the paper that we're going to be going through today in class. Okay, so if you've gone and you've done some of the questions, fantastic. All right, because you've already gone and you've already practiced. Okay, we're going to be going through that paper today. All right, you're going to get the paper 2, which we're going to be going through next week as well. All right, so let's see how we go. We're going to start with the first section, okay? And let's start like this. Okay. So when you hit your algebra, apologies, when you hit your algebra, all right, it's always good to remember that they're going to give you a variety of different algebra questions, okay? But it's good to identify which ones that they're asking us for here. Now in grade 11, they've taught us some different skills this year, okay? You know that, all right? You know your basic algebra. You've been doing algebra, guys, since grade 8, okay? I'm hoping that you really enjoy algebra by this stage, all right? But if not, okay, don't stress. Not everybody has their different strengths in maths, just like everyone has their different strengths in life, and that's perfectly fine as well. Okay, we're going to have a look at how to identify what they're actually asking us for in the different questions. So the first question that we've got here, 1.1.1, they've got 2x, open brackets, x minus 3 equals 0, okay? The second question that they've asked us for, all right, and those are the two that we're going to focus on very quickly. They've got 3x squared minus 2x equals 4. And then the difference between these two is that the second one, they've got in brackets, correct to 2 decimal places. So that's really something that they brought in this year in grade 11, okay? This whole correct to 2 decimal places thing. All right. When they ask us correct to 2 decimal places, okay, what are they actually asking us to do? Who can tell us in the chat? What are they asking for, guys? Come on. What are they telling us? When they say correct to 2 decimal places, what are they actually telling us? What do they want? What do they want to see in our answer? Okay, fantastic. Well done. All right. they want us to use, I'm just going to take this up because we're going to focus on those two. They want us to use the quadratic formula. Great. Okay. They haven't asked for the quadratic formula in number 1. So are we going to use the quadratic formula in number 1? No, we are not going to go and waste our time. Okay. Also, all right, look at your mark allocation. All right. For number 1, here, you've got 2 marks. Okay. Are they going to ask for a quadratic formula if they're giving you 2 marks? No. All right. So that is how you can identify what they're looking for in these questions. Number 1.1.1, they've given us a sum. There's nothing in brackets, and it's for 2 marks. Okay. They're not asking for a quadratic formula. Number 2, in brackets, they've got correct to 2 decimal places. What are they looking for? They're looking for a quadratic formula. Okay. So for number 1.1.1, let's see how this goes. Can you guys tell me, is this screen a bit too small for you? Just tell me in the chat. Are you still able to see the question next to where we're writing? You good? Okay. I will go back and make the question bigger a little bit later on, but for my writing, I promise you'll be able to see my writing. I'm going to write quite big. So here we go. So I'm going to have 1.1.1. All right. It's got 2x, open brackets, x minus 3 equals 0. So the sum is already equal to 0. Okay, the sum is already equal to 0. I'm all good. I like it when something's equal to 0, and I've got brackets and things going on here. So nice, easy sum. They taught me this last year in grade 10. I'm going to say 2x equals 0, or x minus 3 equals 0. So therefore, x will be equal to 0, or x will be equal to 3. Okay. Nice, easy one out the gates. All right. Okay, this would be a level 2 kind of question. Level 1, level 2. Okay, probably level 2 because it's a routine procedure. All right, nice, easy 2-mark question. Done. All right, 1.1.2. 1.1.2, you guys told me, what are they looking for? They're looking for the quadratic formula. So I've got 3x squared minus 2x equals 4. Well, to use the quadratic formula, I need to have an a, a b, and a c. At the moment, I have it equal to 4, so that's not going to help me. So I'm going to have 3x squared minus 2x. If I want to have an a, a b, and a c, what needs to happen? I need to have it equal to 0. So I'm going to bring this 4 across. When I bring the 4 across, it becomes a negative. Now, remember I said to you guys, those level 1 and level 2 questions, a lot of people are like, oh, you know what? I'm not going to practice the level 1 and level 2 questions. I'm just going to skip that and I'm going to go straight to practicing all the level 3 and the level 4 questions. This is like what we call bread and butter. So like where you are making your small marks. Guys, you need that 55%. You need to make sure you're getting that grounding of that 55%. So you need to practice these small marks. Okay, make sure you're practicing this. All right, this is where you make the small mistakes, where you forget to make it a negative because you forgot to go and practice these skills. Okay, go practice this. All right, make sure you've got it down. I like to go tell myself now, a equals 3, b equals negative 2, c equals negative 4. Just a habit I get into. It makes more sense for me. I like to have everything written down. Okay, all right, so x equals negative b plus minus square roots b squared negative 4ac all over 2a. Okay. All right. Be careful. I see somebody saying they tried the quadratic formula and they got undefined. All right. There might be a reason for that, and I'm going to show you usually what the reason might be. Okay. When you put this into your formula now, you're going to have negative, okay, because x equals negative b. And what is b equal to? B is negative 2. So when you substitute in b, you need to make sure you've got brackets and it's negative 2, okay? plus minus square roots, again, brackets, -2, minus 4, a is 3, c is -4, all over 2 brackets 3. Okay, again, be careful, those small little issues that you may get along the way. All right, okay. So therefore, x will be equal to, all right, I'm seeing some of you are giving me the answers there. Thanks, guys, because I left my calculator in the other room after I still told you guys to fetch your calculators. So thanks so much for the help. X equals 1,54, or x equals -0,87. Awesome. All right. Now, you don't have to learn that quadratic formula off the heart. Yes, it's going to be on your formula sheet. Okay, x equals -b plus minus square root b squared -4ac over 2a. It's on the formula sheet, so no, you don't have to learn it off the heart. But to have to go and find it on the formula sheet and write it down, and it is kind of a hack. All right, but remember, okay, in the exam, you stressed. All right, you have been studying. Most of you do not follow the advice of your teachers and your Watobe tutors and don't go to bed early the night before, even though we tell you to. You stay up and you study so late, all right? You should get a formula sheet, Cassandra, most definitely, yes, all right? But you will find that on the formula sheet. X equals -b plus minus square root b squared -4ac all over 2a. Okay, it should be on your formula sheet. A formula sheet should be given to you guys. I'm really sorry that you haven't been given formula sheets before. Hopefully you'll be given them in the exam this time. In your matric final, you will definitely be given a formula sheet though. Okay. All right, let's go look at our next question. So we're going to go back to looking at a full screen. Next two questions. Okay, next two questions. All right, I've got, first of all, an inequality. Okay, and that brings with it some of its own issues, inequalities. Okay, I quite like inequalities. When I was in school, I didn't have, I'm not going to blame the teacher. All right, we so good at blaming teachers. I know, okay, fine. All right, but actually, I'm just going to blame the teacher. I didn't have the best teacher in grade 11, okay, so I didn't really understand what she was talking about when she explained inequalities to me. Okay, it went straight over my head. I was like, what are you talking about? Okay, but she never explained it to me using what I'm going to show you guys today, okay? My grade 12 teacher, I had a different teacher the year after, and she used this way of showing it to me. And ever since she used this way of showing it to me, I've never turned back, okay? This is the way that I do inequalities. All right, if you use this way, awesome. If you use a different way and your teacher just taught you a different way, guys, go and use the way that makes sense to you, okay? Some people in my class that year when I was in grade 11, because grade 11 is such an important year, all right? Some people in my class, they swear by the way that our teacher taught us that year. I did not understand what she was talking about. Okay, so it all depends on what you understand, all right? So let's have a look at this inequality story, because it's really important that you do understand inequalities. All right, so if we're looking at this inequality, it says 1.1.3, x minus 1, 4 minus x, less than or equal to 0. Now, what that actually is, if we had to take that out of the brackets, okay, that's actually a parabola. Okay, it would give us like x squared, what would that be? Something like, I don't know, minus 5x minus 4, something like that. So it would actually be a parabola. Okay, so if you had to take that out of the brackets and you had to expand it all and all the rest of it, you would actually get a parabola here. That's what that would be. Okay, that whole thing, when you had to expand that sum, it would be a parabola. All right, so if we're looking at this, okay, we're going to get x minus 1 greater than or equal to 0, or 4 minus x greater than or equal to 0. So x must be greater than or equal to 0, or 4 must be greater than or equal to 0. Oh, sorry, what am I saying? Oh my goodness, I'm just thinking of my trauma from grade 11 rather than the maths here. 1 and x. Okay, now those two things can't both be true. Okay, so those two things can't both be true. All right, so we need to make it into one statement, in other words. Because this is a parabola, what we're going to go do is we're actually going to go put this onto a number line. It's a parabola. Remember I said to you, if we had to take it out the brackets, if we had to expand it, it would be a parabola. So let's go put it onto an x-axis. So here's x. All right, there's the x-axis. Okay, my values are 1 and 4. So here's 1, and here is 4. All right. If I had to take it out of the brackets, what would happen to x? Okay, so I would have x times 4 would give me 4x. X times negative x would give me negative x squared. All right, which means that the parabola would be a negative parabola, hey? So it would be a negative parabola. My parabola would look like that. Let's put 1 and 4 in here. Okay, I'd have a sad face parabola, a negative sad face parabola. All right. They're asking me, okay, where is this parabola? Okay, where is this parabola here? Where is it greater than 0? So if I'm looking at this drawing that I just drew, where is this drawing greater than 0? It's greater than 0 from here all the way to there. All right, can you see it? Awesome. Of course, Michaela, of course I can explain the parabola part again. Let's have a look. Okay, so, oopsie daisy. Oh, where did it go? All right, so I'm going to explain the parabola part again. Okay, I'm just going to go to one page. Okay, so I'm looking at the sum first of all. Okay, so if I'm looking at the sum, all right, and I say x times by 4 gives me 4x, x times by negative x times negative x gives me negative x squared. So I know I'm going to have a sad face parabola, all right, because if it's negative, it's a sad face parabola. So I go and I draw in my sad face parabola, all right. Then what do they say to me? They want to know, where is my sad face parabola above 0? Okay, where is my sad face parabola above 0? So remember that for parabolas, here is above 0 and here is below 0. All right, so from 1 all the way to 4, my parabola is above 0, which means that if I go and write this in, I'm going to go say, let's pick a pen. I'm going to have 1, sorry, not negative 1, apologies guys. I'm going to go say 1 is less than or equal to x, which is less than or equal to 4. Okay, remember, what is an inequality? An inequality is just a parabola. You're looking where the parabola, I'm going to bring it back up, you're looking where the parabola is above 0. Okay, where is the parabola above 0 here? It's above 0 between 1 and 4. And that's how I do it. Okay, I remember some teachers use like negatives and positive signs. Guys, do it that way. That's how my teacher used to do it as well. I didn't really understand that way. Okay, ma'am, I thought that that was negative. So how is greater than 0 in some parts? So Tando, the parabola is a negative parabola. I agree with you. Absolutely, the parabola is a negative parabola. But where is the parabola, okay, positive according to the graph, as in, like, if we had to draw in, so what I'm going to do here is I'm going to go and draw the y-axis in here for you. So this is where the y-axis would be here. Here it is here. Okay, so this whole graph, this is the f of x. That's the same thing as saying f of x. In other words, y. All right, so what it's saying is, where is the graph positive? All right, where is the graph positive? It's positive between 1 and 4. Above, okay, is going to be positive. Anywhere below is going to be negative. Okay, all right. So the parabola is a negative parabola. It's a sad face, all right? However, okay, the graph is greater than 0. So its y values are greater than 0 between 1 and 4. Okay, and that's how you do it. You draw out your parabola and you go see where is it positive that way. All right. Let us move on. So make sure that you've taken a screenshot of that. I hope that for some of you, if it didn't make sense before, okay, this kind of inequality question, I hope that it does make sense now. If it still doesn't make sense, all right, go and get another practice question like this. Go and do another paper, find another question. And when we have our third workshop, guys, in 2 weeks' time, bring that question to our workshop and I'll explain it again. Okay, I'll explain it again. Tando's asking, do we get a mark for the graph? No, Tando, you don't get a mark for the graph, but the graph is there to help you to get the final answer. Your mark is going to come in here. So your mark is going to be, all right, here. I'm just looking here, Tando, apologies. So you would actually get a mark for your graph and you would get 2 marks for your final answer. Apologies, you do get a mark for your graph, yes. So you get a mark for doing some kind of working, whether it's your graph, whether it's showing critical values, some kind of calculating that. Yes, you do get a graph. Apologies, Tando, yes. Okay. All right, guys, let's look at our next question. So our next question, we have a root. Okay, so let's do a dual page display again so we can have 2 on the page. Okay, so we've got the square root of 5 minus x is equal to x plus 1. Okay, 5 marks. 5 marks. What happens when we see 5 marks? What happens to us? We start thinking that's our level 4. I know that. I know you guys do that. Okay, you see 5 marks, you start thinking that's the hardest question. This is my level 4. No, it's not. Okay, guys, this is not the level 4 question. Can you believe it? All right, this is not the level 4 question. Okay, this question is a mixture of level 1 and level 2. It's not even level 4. This is a mixture of level 1 and level 2. It's 5 marks because you need to spend 5 minutes on it and then move on. All right, so you set your brain up to think this is the hardest question and it's not. So be careful. Watch out for that. Good. Well done. 5 marks, 5 minutes. Move on. Let's go. So the question is 1.1.4. Square root 5 minus x equals x plus 1. Okay. All right, now, I wish that I got to teach the grade 11s every single week, but unfortunately you already have a teacher, which is, you have the best teacher, you do, I know. So Mr. Hugo and I are the dynamic team that then takes the grade 7s every week, okay? Now, why I'm telling you that is because at the moment, we have been teaching the grade 7s about equations, which is what we've got here, okay? And even in grade 7, this is where it starts, which is why I'm saying this to you. Because what do we teach in grade 7? Okay, Mr. Hugo is my witness here. We tell them, whatever you do on the one side, you must do to the other side. You've been hearing this for years and years and years. You've been hearing this since you were in grade 7. Okay, then the other night, I taught the grade 9s because the grade 9 teacher wasn't available for Watobe, all right? I did equations with them. Do you know what I told them? Whatever you do to the one side, you must do to the other side. Guys, it's been the same since you were in grade 7. grade 9, and now you are in grade 11. Okay, whatever you do to the one side of an equation, you have to do to the other side of the equation. We cannot work with square root signs. You've never been able to work well with square root signs until you get into university and you know how to work with surds and all the rest of it, then fine. Okay, if you're going to go study mathematics at university, then you'll learn how to deal with that then. Let us get rid of a square root sign. Okay, what is the opposite of square root, please? In the chat, opposite of square root, please. Help me out. Don't make me teach myself here. What's the opposite of a square root? Come on, I'm throwing you easy balls. Thank you. Squaring. The opposite of a square root is to square. So whatever I do to the one side of the equation, I must do to the other side of the equation. So to get rid of the square root, I need to square. Okay. That square root sign is over the whole side of that equation, which means that I'm going to square the whole side of that equation. Whatever I'm doing to the one side, I'm going to go and do to the other side, everybody. Okay? All right. I know that this seems like basic things, and you're like, ma'am, why are you drilling this into us? Because in an exam, you will forget. Okay? Make sure you remember whatever you do to the one side, you do to the other side. Grade 7, grade 9, grade 11. Same thing that I've been telling you guys. Okay? Literally, over the last maybe 3 weeks, this is like literally the same thing I've told people. All right. So square is going to make the square root sign disappear, and I'm going to have 5 minus x is equal to. All right. I know you're in grade 11. Some of you know how to do the cheat to get rid of the square sign. Okay. If you're in an exam though, I always like to write the brackets out twice. Okay. And then I like to expand. But all up to you. If you're confident to do the cheat, you're more than welcome to do the cheat. So I'm going to have plus x plus 1, 5 minus x squared, sorry, equals x squared plus 2x plus 1. Okay. All right. Now, we're down to x squared, which means that I can have numbers on one side, letters on the other side normally, but because I've got an x squared, I want everything on one side, and I want it to all equal to 0. I don't like working with negative x squared, okay? So I'm going to take everything over to where x squared is positive. So I'm going to have 0 equals x squared plus 2x plus 1 plus x minus 5. 0 equals x squared plus 3x minus 4. Okay. I'm going to go put that into brackets. Here again, you could use the quadratic formula if you really wanted to. All right. You could use the quadratic formula. Okay. All right. So I've got, therefore, x must be equal to negative 4 or x equals 1. Now, okay, I need to just give you a warning light here, like warning light, sirens, everything should be going off in your head here. Because you've got a square root sign, you need to go check your answers. Okay, you need to go check your answers. So I've got 5 minus negative 4 square rooted. All right, so we need to go check whether these answers work or not. In other words, is what I'm saying to you. Okay, so if I had to have, so I'm just going to go do a check here on the side. The square root of 5 minus negative 4, it would give me 5 minus negative 4. Again, I don't have my calculator on me. Sorry, guys. That would give me plus or minus 3 here. All right. Check it out. Am I right? Check me. Check my answers. Okay. All right. On the other side, okay, x plus 1, so negative 4 plus 1 gives me negative 3. So that answer, are we okay with it being x equals negative 4? Happier with the answer being negative 4, everybody? Yeah? Seem okay? All right, cool. If I had to have 5 minus 1, it would give me the square root of 4. Okay, what's the square root of 4? Square root of 4 plus or minus 2. Okay, and 1 plus 1 gives me 2. All right. Am I happy with x equals 1? All right. So I did have somebody say to me that they're not happy with x equals -4. All right. Well, I think it was Irene. Anyone else who wants to tell me why x equals -4 is not right? Who wants to tell me why x equals -4 is not right? Anyone who's willing to lift their hand and talk to me? Anyone? Come on. Somebody talk to me and tell me why x equals -4 is not right. Awesome. There we go. Thank you. All right. Okay, if I say your name incorrectly, you're going to help me. Okay, so Khali. Hello.
What's your name?
How are you?
I'm great.
Good. Will you pronounce your name for me correctly?
Kalinapo.
Kalinapo. Okay, thank you so much. All right. Why is x equals -4 not correct?
No, ma'am, it is correct, ma'am. But
it is correct.
Also,
okay.
So the 3 is also correct. They're both right.
They're both right. Okay, cool. So you're saying they're both right. Okay, cool. Thank you so
Yes.
much. Thank you.
You're welcome.
Okay, cool. All right. Anyone who's saying that they aren't both right? Who says that they're not both right? Anyone who says that they're not both right? Are you all got, okay, I see somebody saying me. Okay, anyone who wants to lift their hand and tell me why. Otherwise, I'm just going to move on. You've got to tell me why. Come on. Someone help me out. Aha. Okay, so you only have an emoji, but I'm going to ask you to answer anyway. So my emoji says, hello.
Hello. Hi.
What's your name?
I'm Khavani.
Hi, Kamani. You tell me, why is x equals -4 not right?
X equal -4 is not right because both sides aren't equal, because when we sub it in, both sides must be equal.
Okay, so explain to me. So I've got 5 minus -4. Okay, and 5 minus -4 gives me?
It gives me, I think, a 3. -3. It gives me 3. But then on the other side, if I sub in -4, it's going to be -1, which doesn't make sense.
Gives me -1. So if I've got -4 plus 1, -4 plus 1 gives me -3.
-3. Sorry.
That's fine. Cool. Okay, I am happy with your answer. I also am rejecting -4, so I'm happy with that. Thank you so much.
Thanks.
Awesome. Okay, so x equals -4 does not work, guys. Okay, and the reason it does not work is because when we sub it in, we get a negative. So x equals -4 does not work. I completely agree with you. I do agree. All right. So x equals -4 does not work. Awesome. Okay. All right. So I'm just seeing here, Kirsten's asking me, ma'am, for the previous inequality, how do we know when to, I'm missing. Do we know to put x in the middle of our answer, or put an and or an or in between? Okay, so Kirsten, I'm just going to ask you to go back and just watch the video on that and just make sure that you understand how we did the parabola again, because that's how you can tell. Okay, so make sure you go back and you can see how we did the parabola and how we saw that it was positive in between those 2 points. That's why we didn't need to put an and or an or in between. Okay, guys, we are moving on to our next section. So let's go have a look at what we're looking at next. Okay. Now, we all know that this paper follows the same route each time. So each time we're doing the questions, we're pretty much following the same routes in paper 1. Okay, so now we've done our geometry. I keep saying geometry. I've got geometry on the brain, I think. I just can't wait for next week when we're doing our paper 2. And we've done our algebra. Okay, we're now going to be moving on to more algebra, but we're solving for x and y simultaneously. Okay, x and y simultaneously, that's no, you're getting an x and y simultaneous question. That's the next one that's coming in. All right, so let's go have a look at this next question. I'm going to draw it nicely on this next screen for you. So I've got question 1.2. You'll notice, or I'm hoping you're noticing, that I am numbering my questions as they're numbered in the question paper. Another really good exam tip for you guys. Make sure that you are numbering your questions as they're numbered in the paper. So I've got x plus 4 equals 2y. Okay, I'm going to leave a little space in between there for us. And I've got y squared minus xy plus 21 equals 0. Okay. So again, I pretty much have a layout for every question that I do. Okay, it's a standard layout. All right, I always believe if you stick to the same standard layout that you practice when you're doing your practice questions, when you get to the exam, you're less likely to forget what you're doing. Okay, it makes you more confident. All right, so once you get a layout that works for you, make sure that you're sticking to the same layout each time. So for me, I like to write my 2 equations out. I leave some space in between each one so that when I go back and I'm looking at them, okay, I can see that the second equation that I've got written here has a y squared in it. I don't want to deal with anything that's got a squared in it, all right? Okay, I want to go for the easier equation. So if I'm looking at that first equation, it's got no squares in it, okay? So this is the one where I'm going to isolate one of my variables. Isolate, make it come by itself, okay? It needs to be by itself. All right, so it's got x equals 2y. I'm taking the 4 across, minus 4, and I'm going to make this equation number 1. If that's equation number 1, this is going to be equation number 2. So always try, okay, to pick the equation that's much easier to isolate the variable in. All right, and the one that's always easier to isolate the variable is where you don't have any squares. You can do it where you've got a squared, but my goodness, you're going to get yourself all knotted up. All right, next, I'm going to say substitute 1 into 2. So I'm substituting 1 into 2. Okay. So what does that mean? It means that wherever I see x, I'm going to write 2y minus 4. I'm going to go put some brackets here for myself so that I can tell that I need to substitute that whole thing in. So I've got y squared minus, instead of seeing x, I'm going to see 2y minus 4y plus 21 equals 0. Right, you go from there, guys. Go try it out. Go try it out. Especially those of you who are working really hard. I'm seeing there's loads of people who've got pen and paper here in the camera. So well done. Okay, well done, guys. Okay, go try that out for me. Okay, go expand it. Take it out of the brackets, in other words. Right. Okay, see how you're going. while you guys are busy, I'm going to check in with Mr. Hugo, because Mr. Hugo, you've been so quiet there. I haven't heard you for like a full hour. How are you going, Mr. Hugo?
I am doing well, thank you. I was just about to unmute and remind the students that if anybody is maybe quick with a sum and they're done already, scroll right up to the chat where I shared some helpful information, and specifically 2 messages there about tips for the exam, guys. So there I shared some stuff that I've put together over the years, teaching and also studying and writing these exams myself and whatever, where you can, there's just some pointers and some tips, guys. Get enough sleep and look at the question, the mark allocation for the questions and all those usual stuff that might sound silly, but I mean, I think just go through them, guys. I don't want to spam the chat and send them again. Just scroll right up. I shared it there in the beginning. If you have time, go check out the tips and tricks for exams to do your best, the best you can.
Thanks so much, Mr. Hugo. That's so useful. I think it's really important, guys, that you're looking after not only your physical health, your mental health as well. Definitely. Absolutely.
Okay, I see that I am getting questions to share it again. So I might just send it again, quick sticks. If you guys don't mind me spamming the chat, I do think it will be helpful though.
That would be wonderful. Thanks so much, Mr. Hugo. All right, so while Mr. Hugo is sharing that, and I see lots of people putting the answers through, well done, guys. I'm so proud of you. Okay, so you went and expanded the brackets, okay? A reminder, and I see lots of you did it, so well done, to not forget that this is a negative before here, okay? So what I sometimes like to do is I would sometimes go and remind myself that actually I need to move this y and put him here. Okay, that helps me out a little bit, all right? Because then I'm going to multiply in the negative y instead of just multiplying in the y, all right? Okay, then what did I do at this step over here? Okay, I took away the negative. Now, how do I take away the negative? I multiply everything by a negative, okay? So at this stage now, I need to put it into brackets, all right? So I'm going to get y minus 7 and y plus 3. Guys, if you're still struggling to find your factors, all right, for a quadratic like this, if you're still struggling, please don't stress. Loads of people still struggle with finding their factors, okay? It's nothing to be worried about. You just need to keep practicing, okay? Another way to do it, all right, that's going to really help you out, it might be a little bit longer, but go use the quadratic formula. What's wrong with using the quadratic formula to get your factors? Okay, you've got the formula sheets. Hopefully, if all your schools, some of your schools you've said, yeah, don't give you the formula sheets, okay? But if you've got it stuck in your brain, go use the quadratic formula and use to get your factors. Really nice, easy way to do it. All right, so you've got y equals 7 or y equals negative 3. How are you going to go get x now? You're going to go put it into the equation. Which equation should you use? You should use the easy equation. Okay, which equation is that? Equation number 1. All right, so you're going to have x equals 2 times by 7 minus 4, or x equals 2 times negative 3 minus 4. So x equals 10, or x equals negative 10. Okay. All right. I see Trisha saying you can also use a calculator. You can also use the calculator if you've got that really fancy, I think it's like a silver one with the solar power thing, that really fancy one, okay? But not all of us bought that really expensive one. If you just bought the standard scientific calculator, I know that you can't do it on all of them. So yeah, but thank you, Trisha. Yes, you can also do it on some calculators. You can get the factors, yes. All right. Okay, don't all go now and be like, oh my goodness, why doesn't my calculator do it? Guys, not all of the scientific calculators can do it, okay? All right. Okay, let's have a look at our next one. So that was our simultaneous equations. Again, my tip here to you guys is when you're practicing, use a system. Okay, so my system is I write my equations down, I leave a space between the two, I look to see which one is the easier one to isolate a variable. What does isolate mean? Put it by itself. Okay, then, all right, I tell myself this is equation 1, this is equation 2, substitute 1 into 2, and I move on from there. Stick to the same format each time. Every single time you do it, you stick to the same format. If you're practicing that format when you're practicing for exams, you use that same format when you write your exam. You're going to not go wrong each time. Okay. All right, guys. So we're going to move on a little bit from algebra so that we can move on to some more questions. Like I said to you, go practice the rest of that in your own time. When we come back in 2 weeks' time to do our wrap-up of all the papers, and if there's something that you want to go through, I'm more than happy to do it then. Okay, so let's go have a look at what they've got in the next question. All right, question 2. In question 2, okay, in question 2, we now move on and we've got some exponents. You know exponents are coming, all right? Exponents is a really nice one that the teachers like to ask, okay? You guys spend quite a bit of time doing exponents. It's a whole section in grade 11, okay? So let's have a look at this exponents question, all right? This first one is another famous one, mainly in grade 10 though, not really in grade 11. I think it's mainly in grade 10 where students come out the exam and they're like, we never learned that. You have learned it, you've learned how to do it. You might not have done it in class, but you have learned how to do it. Okay, so let's have a look at this first question. So we've got 2.1. 5 to the power of 2015 plus 5 to the power of 2013 over 25 to the power of 1006. Okay. All right, I'm gonna give you 2 minutes to go try it. All right, go have a look at it. Okay. Guys, so remember, I'm not going to go through every single question. I'm going to go through a selection of questions. I want you guys to go try the paper. The paper's being sent to you. All right, if there are questions that you are struggling with, and when we come back in 2 weeks' time and you want me to go through those specific questions, I definitely will do those questions in our workshop in 2 weeks' time. I'm more than happy to do it then. Absolutely, no problem. All right. But our time goes so quick together, so I want to make sure that we're getting a maximum of a mixture of all different questions today. All right, let's have a look. So the ideal here, okay, is that we're pulling out common factors. All right, we're looking for common factors here. So if we're looking at 5 to the power of 2015 and 5 to the power of 2013, guys, do you agree that we can pull out a common factor here? Okay, we can pull out a common factor. All right, so if I'm looking at that, all right, we can definitely see that 5 is a base. Okay, I can definitely tell that 5 is most definitely a base. Now, with exponents, what happens when we have the same base? Okay, when we have the same base, what happens? All right, well, if I have the same base, I can do the following. I can say the base times by the base. Oopsie. Oh, geez. Okay, let's see if pen is tired after this week. All right, so when numbers have the same base, what can happen? I keep the base and I add the exponents. So numbers that have the same base, you keep the base and you add the exponents. So if I have a base of 5, then I can take 2015 and I can say, well, 5 to the power of 2015 times by 5 to the power of 2 is the same thing as saying 5 to the power of 2015, because same base, add the exponents. Plus, so what I'm going to do here, guys, actually, to show you that it's the same thing, is the following. Let's do this. All right. Especially for those who are telling me, man, I've been struggling with ones like these. I'm going to do this. So this first number was 5 to the power of 2015. So I'm going to take this number and I'm going to show you in blue what I'm going to do with it. I'm going to make it 5 to the power of 2013 times by 5 to the power of 2. So what did I do with this number? I changed it from being 5 to the power of 2015 and I made it 5 to the power of 2013 times by 5 to the power of 2. Why? Same base, same base. I can keep the base and add the exponents. All I did now was I did the opposites, all right? I took that one that had a base with an exponent and I split it up. Plus, that same one is 5 to the power of 2013 over. All right, I'm going to change this one's color for you. This one on the bottom was, let's make him, put him in black. 25 to the power of 1006. Okay. All right. What is 25 the same thing as? Now, on your scientific calculators, especially if you've got a Casio one, all right, if you say, okay, 25 equals shift factor, all right, if you say 25 equals shift factor on your Casio calculator, it'll tell you 25 is the same thing as saying 5 to the power of 2. So I've taken that 25 and I made him 5 to the power of 2. And on the outside of this bracket, it's 1006. Okay. 1006. So what have we done? Okay. What have we done? We took that number that was in blue. I've done it in different colors for you so you could see what we were doing. I took that number that was in blue, 5 to the power of 2015, and I made it 5 to the power of 2013 times by 5 to the power of 2. Why did I do that? Because I can split it up. All right, I'm allowed to do that. I can split it up. Okay. Why can I split it up? Because when we have the same base, you keep the bases and you add the exponents. Plus 5 to the power of 2013, I'm happy to leave it like that. We're good. On the bottom, 5 to the power of 2. I made 25 5 to the power of 2 to the power of 1006. Okay. Trisha just said to me, ma'am, can we not take out a common factor at the top? Exactly, Trisha, that's my plan. Well done. That's what I want to be doing. So on the top now, on the top, what can I see? Now I can see I've got a common factor. I've got 5 to the power of 2013. So I'm going to take out 5 to the power of 2013 as a common factor, and I'm going to be left with 5 to the power of 2 plus 1. All right. Over on the bottom, okay, I've got an exponent in the bracket. I've got an exponent outside of the bracket. So I'm going to have 5 to the power of 2 times by 1006 is going to give me 2012. All right. Puleng, where does 1 come from? So Puleng, where does 1 come from? Okay, if I had to multiply this back in, Puleng, so if I had to multiply it back in, all right, 5 to the power of 2013 times by 5 to the power of 2 would give me 5 to the power of 13 times 5 to the 2. And 5 to the power of 2013 times by 1 would give me 5 to the power of 2013. Okay, so where does the 1 come from? The 1 comes from this over here. It comes from, I'm going to put it in this color here for you. It comes from here. All right, I hope that that makes sense, Puleng. I took it out as a common factor. No problem, of course, sure. Okay, so let's see where we at. Okay, I've got 5 to the power of 2013 on the top. I've got 5 to the power of 12 on the bottom, guys. So 5 to the power of 2013 on the top. I've got 5 to the power of 2012 on the bottom. What can I do? What can I do here? Can I perhaps same base, can I subtract the exponents? Yeah? Happy with that? Same base, same base. Okay, so same base. I'm going to be left with 2013 minus 2012. I'm left with 5 times 5. Open up a bracket. 25 plus 5 to the power of 2 plus 1. Okay. All right. And that leaves me around 26 times by 5. 26 times by 5 gives me, am I right, 130? Okay, so that's the way I would do it. That's the way I would do it. There are different other ways to do it, I'm sure. All right, that's the way that I find the easiest. Okay, let's see. I have a hand up. Thank goodness I'm not talking to myself. Let's see if I can unmute you. I might have to ask Mr. Hugo if he can help me out because there we go, Mr. Hugo. I was just about to say my screen seems to be frozen again. Mr. Hugo, would you be able to help me out and just unmute our student that has their hand up?
She is unmuted. Oh, there she's muted again.
Oh.
Unmute me again.
Thank you so much, Mr. Hugo.
It's
All
muted.
right. Nasha?
Hi, ma'am.
Hi, what is your question? While I'm getting the screen working, what's your question?
Ma'am, can I please see the screen?
Of course, I'm going to share the screen with you right now. It's just a little bit unmuted at the moment. It's with one of our questions. Hold on 2 seconds for me. I'm just going to get it working. I think our screen's having a bit of a Saturday. That's what's happening here, hey? All right, let's go see. There we go. Okay, talk to me.
Okay, ma'am, I just wanted to find out how, so it's 1, 2, 3, the third step, ma'am.
Yeah.
How do you, 5 to the power of 2013 turn into 1?
How did it turn into 1? So what I did, it's kind of like, I'm gonna go here. Do you agree with me? You see where I had this highlighted one? Do you agree that I could say that there's like a 1 hiding here, and it's 1 times by 5 to the power of 13? Because 1 times by anything is 1, hey?
Yes, ma'am.
All right. So when I take that out the brackets, what's going to happen? When I take them out as a common factor, what's going to be left there to tell me that there was something there? I need to have a 1. Remember, when you take out common factors, okay, when you take out common factors, all right, there must always be 1 left, a 1 to show that there was something there originally.
Yes, ma'am.
Does it make sense?
Yes.
Okay, cool. All right, good.
So which one is the common factor here?
The 5 to the power of 2013. So 5 to the power of 2013 was the common factor. And when I take it out, I need to have a placeholder there to show that it was there originally. And so the placeholder is the number 1.
Oh, okay, ma'am.
Okay, makes sense.
Thank you, ma'am.
You're welcome. No problem, Nashan. All right, guys. So there is a different way to do it, guys. And the different way to do it, I have inside the memo for you guys. Okay, so there is a different way to do it. It's in the memo for you. Okay, the different way to do it is to pull out 5 to the power of 2013 and to do it that way. I like doing it this way. It's a different way, just to show you that there are a variety of ways to do it. Ma'am, how did you move from the 3rd step? So 1, 2, 3. How did I move from the 3rd step? Let me go and show you very quickly. Okay, so how did I move from the 3rd step? Let's go see. All right, so in the 3rd step, I've got 5 to the power of 13 over 5 to the power of 2012. So if I look at that, I'm going to say 5, I've got 5, so 5 and 5. Okay, so what can I do? I've got common bases. I've got common bases and I'm dividing by common bases, I can keep the base and I can subtract the exponents. Hey, remember that rule? Okay, you're keeping your exponent rules. Times by 5 to the power of 2 is 25 plus 1. So 5 to the power of 2013 minus 5 to the power of 2012 is 5 to the power of 1, which is 5, times by 26, which gives me 130. Parable, I hope that that makes a little bit more sense now. All right. Okay, guys. So let's have a look at the next question they've got. Okay, in the next questions, there are some really nice basic exponent questions. Again, guys, go and try those exponent questions out yourself. They are 6-mark questions, 6 minutes. I want you to try that for me. Come back in 2 weeks in our final workshop. Let me know if there's ones that you want to go through there. Okay, what I would like to go through is I would like to have a look at one of your number pattern questions. Okay, and the number pattern question that I'd actually like to go through is I'd like to go through your quadratic number pattern, because that's new to grade 11. So that's new grade 11 work. So I want to have a look at this quadratic number pattern today. All right, we've got 11 minutes left. Trisha, ma'am, will there be a memo? Trisha, you should have been sent the memo. If you haven't been sent the memo yet, Mr. Hugo and I will find out for you. You guys should have been sent the paper and the memo. If you haven't been sent the memo yet, I'm sure that they will probably send you the memo straight after this workshop. Can you guys just confirm to me, were you sent the paper already? Have you been sent the paper? And just tell us in the chat, Mr. Hugo and I. Yes, no, yes. Yes, okay, awesome. But you haven't been sent the memo, am I right? You haven't got the memo yet. Not yet. Okay, so I think that the memo will come after the workshop, but go through the paper, make sure you understand. If there's questions you don't understand, then we will go through that in the 3rd workshop as well. Okay, let's go through this quadratic number pattern. All right. I tried as best as possible, guys, when I set the paper for you and I did the memo as well, because I knew that we only have an hour and a half and that's such a short workshop. Oh my goodness, it's just so intimidating to only have an hour and a half. But I tried as best as possible to make the memo as thorough as possible for you guys. So I put a lot of detail in the memo. You'll see the memo is many pages. Apologies. Okay, apologies in some respects, but also not in some respects, because it means that you guys have a lot of detail to go through. Okay. Let's have a look at the quadratic pattern. So this quadratic pattern looks as follows. It says the quadratic number pattern is 41. Sorry, this quadratic number pattern is, okay, this says 4LP. It should be 4P, P, 11, Q, and 22. So there is a one of these missing. Yeah. One of these thingies, like that. Okay, so it should be the quadratic number pattern is 4, P, 11, Q, and 22. All right, so that's the quadratic pattern. What does a quadratic pattern mean? It means there's more than one difference. It means you're going to have a first difference and you're going to have a second difference. You were taught this year in grade 11. It's new grade 11 work. It's beautiful grade 11 work. It's grade 11 work that you can learn how to do in steps and sequences. Another one of these ones that once you learn how to do it one way, keep that way, because it means you're going to practice it that way from now onwards. So for 4.1, they say to you, show that P equals 7 and Q equals 16. All right, so 4.1. I'm going to go take my pattern quickly. 4, P, 11, Q, and 22. Okay. All right, guys. Single page. So I've got 4, P, 11, Q, and 22. Okay. I know that I'm going to have the following. Okay. In my first line of differences, I'm going to have P minus 4 to get that first difference. I'm going to have 11 minus P. I'm going to have Q minus 11. And I'm going to have 22 minus Q. Okay, so what am I doing each time? I'm just going to do it again for you. All right, what did I do? Okay, I took my numbers. So I did 4, P, 11, Q, and 22. Okay. I told myself that between these two numbers, I say P minus 4. So I take my second number minus my first number. My second number minus my first number. My second minus my first. My second minus my first. Okay. But it's quadratic. So I know that there's more than one difference. Quadratic, more than one difference. Okay, more than one difference. Yes, that was a comma. I know I also thought it was an L. It should have been a comma. So there was a mistake when there was a translation, guys. Apologies. Make sure you put a comma in there. Make sure you put a comma in there. Apologies. It does look like an L. You are right. Put a comma in there. Put a comma. All right, so that's the first one. Let's do the second line. So for the second line, I'm going to have, okay, for the second line, I'm going to have, all right? So this is negative P. Oh, sorry. Let's do it this way. Let's just write it like it is. Okay, so I'm going to have 11 minus P minus P minus 4. For this one, I'm going to have Q minus 11 minus 11 minus P. And for this last one, I'm going to have 22 minus Q minus Q minus 11. Okay, Pulling, you are absolutely right. That is how you get it. Yes. All right. So I need to work out now, how am I going to get P and how am I going to get Q, okay? All right, how am I going to get P and how am I going to get Q? All right. Okay, so go do some calculations. I've helped you out a little bit. Go do some calculations. See what you think. Right, what we thinking? Okay, let's go back to the question. Let's see if we can get some more information. That might be helpful as well here. All right, so the question is, the quadratic pattern has a second constant difference of 1. Apologies, left that out for you guys. There's a second constant difference of 1. So we need to know that there's a second constant difference of 1. So we've already gone and worked out what my second constant differences are. Here is my line of second constant differences over here. Okay, and we know that the second constant difference is 1. So if we know that, then what are we going to say? Well, we know then that 11 minus P minus 4 equals 1, hey? All right, so let's simplify a little bit. So we're going to have 7 minus 2P equals 1. All right, we're going to take 7 across to the other side. So negative 2P equals negative 6. So P equals, oh, what am I doing? Guys, I left out a negative here. Apologies, my goodness. Left out my brackets, left out my negative. There we go, plus 4, apologies. Okay, so I've got 11 minus 2P. My goodness, I think I'm rushing. Let's just calm down. All right, so I've got 50 minus 2p equals 1. Negative 2p equals, take this across the other side, negative 14. P equals 7. That's better. All right. Yes, thank you, Jade. I was rushing. Apologies. Thank you all to absolutely, guys. I was rushing. Apologies. Okay, so I've got P equals 7. All right. Now, am I happy to say the, so now I can go calculate Q in the same way. Okay, I can go calculate Q in the same way, right? Why? Because I know that Q minus 11 plus 7 now, because P equals 7, will give me 1. So I can calculate it this way. So 11 minus what's 22 plus 7. Oh my goodness, I don't have a calculator. Negative 22 plus 7, guys. What's the answer there? 15. Hey, negative 15 equals 1. Q equals 16. Okay. Ma'am, why isn't the second constant difference the entire second line? So the reason why the second constant difference isn't the entire second line is because what happens is your second difference is always then your difference between your first differences. That's how you calculate it. All right. And they told you that those were equal to 1. All right. So calculate that way. All right, guys. So that's how you get P and that's how you get Q. Now, the next calculation that you have to do is you have to go and you have to calculate Tn. So if we were then calculating Tn, and remember, now you're doing a quadratic pattern, well, first you want to go and tell yourself this. First, you want to go tell yourself, well, now I'm going to say, okay, that my number pattern for 4.2, so for 4.2, I'm dealing with 4, 7, 11, 16, and 22. So you actually want to go do the quadratic pattern. You want to go work it out. So here is 3, here is 4, here is 5, and here is 6, and here each time was 1. So you want to go look at your quadratic pattern. All right. Okay. Let's go do the last question together because we've run out of time. Like I said to you guys, the time goes so fast in these boot camps. So we're sticking to the pattern that we use all the time. Okay, the first thing we do is we say, okay, I go tell myself, this is my first line, this is my second line, and this is my third line. I always go tell myself the same thing. So for number 1, I say 2, A, because that's the first thing I know I need to do. I put a number 1 and I say 2A equals. 2A always equals 1, the first constant difference. Right? So A equals a half. Number 2, 3A plus B. So again, remember I said to you, I like to learn things off the heart. So number 1, I say 2A equals, and I put the first difference. Number 2, 3A plus B equals, all right, and I put the second difference there, the first number that comes up there, which is 3. Now I know what A is, so I say 3 is a half plus B, which equals 3. Okay. Take that across to the other side, and I get B is equal to 3 over 2. And number 3, A plus B plus C equals 4. Right, I know what A is, it's a half. I know what B is, it's 3 over 2. I don't know what C is, it's 4. And I'm left with C is equal to 2. So my final sum, Tn equals a half n squared plus 3 over 2n plus 2. All right.